Hi there guys, Ivan here from Uganda and Electricity. Today we are going to be looking at capacitors to learn how they work, where to use them, how to spot them, why they are important. Remember, electricity is dangerous and can be fatal. You should be qualified and competent to carry out any electrical work. Do not touch the terminals of the capacitor as it can cause electric shock. So what is a capacitor? A capacitor stores electrical charge. It's a little bit like a battery, except it stores energy in a different way. It can't store as much energy as a battery, although it can charge and release its energy much faster. This is a very useful, and that's why you will find capacitor used in almost every circuit board. I want you to first think of the water pipe with the water flowing through it. The water will continue to flow until we shut the valve. Then no water can flow. However, if after the valve is open, we first let the water flow into a tank, then the tank will store some of the water, but will continue to get water flowing out of the pipe. Now when we close the valve, water will stop pouring into the tank, but we'll still get the steady supply of water out until the tank empties. Once the tank is filled again, we can open and close the valve as many times we like. As long as we do not completely empty the tank, we'll get an uninterrupted supply of water out of the end of the pipe. So we can use a water tank to store water and smooth out interruptions to the supply. This is same as a capacitor. In electrical circuits, the capacitor acts as the water tank and stores energy. It can release this to smooth out interruptions to the supply. If we turned a simple circuit on and off very fast without a capacitor, then the light will flash. But if we connect a capacitor into the circuit, then the light will remain on during the interruptions, at least for a short duration, because the capacitor is discharging and powering the circuit. Inside the basic capacitor, we have two conductive metal plates, which are typically made from aluminium or aluminum. And these will be separated by a dielectric insulating material such as ceramic. Dielectric means the material will polarize when in contact with an electric field. One side of a capacitor is connected to the positive side of the circuit, and the other side is connected to the negative. On the side of the capacitor, you see a stripe and a symbol. This indicates which side is negative. If we are to connect a capacitor to the battery, the voltage will push the electrons from the negative terminal over to the capacitor. The electrons will build up on the plate of the capacitor, while the other plate in turn releases some electrons. The electrons can't pass through the capacitor because of the insulating material. So eventually the capacitor is the same voltage as the battery, and no more electrons will flow. There is now a build-up of electrons on one side, and this means we have stored energy and we can release this when needed. Because there are more electrons on one side compared to the other, and electrons are negatively charged, this means we have one side which is negative and one side which is positive. So there is a difference in potential between the two, and we can measure this with a multimeter. So where do we use the capacitor? They look a little bit different, but they are easy to spot. In circuit boards, they tend to look something like this. We see them represented in engineering drawing with symbols like this. We can also get larger capacitors, which are used, for example, in induction motor, ceiling fans, air conditioning units. We can also get larger ones, which are used to collect poor power factor in larger buildings. On side of the capacitor, we'll find two values. These are the capacitance and the voltage. We measure the capacitance of the capacitor in the unit of farads, which we show with a capital F, although we usually measure a capacitor in microfarads. This is a small U you see with a little tail with a small f. The other value is our voltage, which we measure in volts with a capital V. On capacitor, the voltage value is the maximum voltage which the capacitor can handle. If you are to exceed this, a capacitor will explode. Why do we use a capacitor? One of the most applications of the capacitor in the larger building is for power factor collection, when too many inductive loads are placed into the circuit. Another very common application is to smooth out peaks when converting AC to DC power. How do we measure a capacitor with a multimeter? We can measure the capacitance and the stored voltage using the multimeter. But remember, not all multimeters have a capacitance factor. You should be very careful with capacitors, as we know they store energy and can hold high voltage values for a long time, even when disconnected from the circuit. To check for voltage, we switch to DC voltage on our meter, and then we connect the red wire to the positive side of the capacitor and the black wire to the negative side. If we get readings of several volts or more, then we should discharge that by safely connecting the terminal to a resistor and continue to read the voltage. We want to make sure that it reduced down into millivolts range before handling it, or else we might get a shock. For the capacitance, we simply switch the meter to the capacitor function. We connect the red wire to the positive side and the black to the negative side. After a short delay, the meter will give us a reading. We will probably get a reading close to the stated value but not exact. Okay guys, this is it for this video, but to continue your reading, then check more for our videos. Please don't forget to subscribe, like and share. As we are continuing to learn more about electricity, don't forget to follow us on YouTube and Twitter. Thank you.